In this video, we will find the sum formula, which is for either this expression where n is finite, or it can be used for this expression where we can say that we have infinite terms. We have the summation of infinite terms. So let's start from this one, and we can rewrite this sum as S is equal to the summation for k0 up to n, a raised to the power a multiplied by r raised to the power k. Now let me expand this one. So for k0 it will be a r raised to the power 0 plus a r raised, then k for k1 this term, and so on. You can follow this raised to the power 2 and up to a r raised to the power n. Now what we can do, let me write one more step, and then r raised to the power 0 is 1, so we have a here. The next term is a r raised to the power 1, so we do not write 1 as power, a r square and so on. It's a r raised to the power n. Now what we can do, this r is known as the common ratio in this sum. So let's multiply this common ratio on both hand sides, on the left hand side as well as on the right hand side of this equation. Okay, so we have a inside, okay, we have a inside plus ar plus ar square and so on, ar raised to the power n. So this can be rewritten. S can be written as ar plus ar square plus ar cube plus so on, and the last term is ar n plus 1. Now we are multiplying r with every term in this summation. Now what if you concentrate on these two equations, this one and this one, and from these two let me find s minus rs, okay, which is equation number 2 subtracted from 1. So if you subtract this the second equation from the first one, just let me rewrite both of these equations. So we have a plus ar plus ar square and so on up to ar n in s. Then we are subtracting the second equation, which is minus ar, I'm just writing it, ar square plus so on. We have ar n and a last term ar n plus 1. So if you want to subtract it, just this is a plus term. So if you want to subtract it, we need to change the sign of these the sign of every term in the second equation. Okay, so let's change this sign. Minus, all becomes minus, and the result what we get, you can see this cancels, all these terms cancels out, and you are left with only two terms, which is a minus ar raised to the power n plus 1. So s minus rs is equal to this one. Now you can take s common on the left hand side, and the left hand side can be written as 1 minus r. You can take a common here, which is 1 minus r n plus 1, and we can rewrite our sum is equal to a times 1 minus r n plus 1 whole divided by 1 minus r. Okay, so we divide both sides by 1 minus r, which is here. You divide both sides by this term. So this is the formula for the sum but for finite n. Now with if n approaches infinity, assuming that our common ratio r is less than 1. So it may be any value less than 1. You can suppose let r is equal to 1 over 2. Suppose it's less than 1. Okay, so r is positive but less than 1. So for this one, if r is less than 1, okay, the absolute value of r, or actually the r is less than 1, then we can what will happen to this term? Concentrate here on this one. Okay, concentrate on this term, which is r raised to the power n plus 1. So if you concentrate on this term, which is r n plus 1, and assuming that n approaches infinity, so if we apply this limit, n approaches infinity, and we know that the value of r, this one, is less than 1. So of course, if this is less than 1 and we have something infinity in the power, this whole term approaches 0. We can just substitute 1 over 2 here, and we can just think of it 1 over 2 raised to the power a very big number, infinity, plus 1 raised to the power infinity. So you see, 1 over 2 multiplied by 1 over 2 multiplied by 1 over 2 times infinite times. So you can see in the denominator you have a very big number, which is r infinity. So the result of this is 0. So this actually approaches to 0. So if this approaches to 0, this term, for n approaching infinity, if this term r raised to power n approaches to 0, so our sum becomes equal to a 1 minus 0 over 1 minus r. So which is actually equal to a over 1 minus r. So this is the expression. So we can say that if the for n 0 to infinity, a raised to the power n, or you can just initially we substitute it a k here. So let me use k here. Okay, in the power is and as index k, a raised to the power k is actually equal to a over 1 minus r. So this is for the case when your upper limit is infinity, when this is infinity, when k approaches infinity. Okay, so if you are k approaches infinity, and keep this in mind that r should be less than 1, so then your formula becomes this one. Otherwise you can use the other formula for finite values here, or a finite upper limit here.